Okay, so what I'd like you to do is pause the video and give this a try. Give these a try. Get the area of this shape here. This is a trapezoid. Then get the area of this, and then this octagon, and then the shaded part of this circle. Okay, so please go ahead and do that, and come back in a couple seconds when you have finished doing those calculations. Okay, so now that you've done that, I'll go through the calculations for these areas. And so first of all, I see this as a trapezoid, and I see that this, now is not marked, but it certainly appears as though these are right angles. What I'm going to do is I'm going to separate this into two shapes. I'm going to separate this into a square and a triangle by, sorry, not a square and a triangle. This will actually end up being a rectangle and a triangle, because this is only 3 centimeters and this is 4 centimeters. So I'll make this into a rectangle and a triangle. And if we know the whole length here is 5 centimeters and this length is 4 centimeters, then this extra part here has to be 1 centimeter, where this is 4, to make up the 5 total. This is 3, which ends up being the height of the triangle, which is 3 centimeters. So we can then find the area by combining those two, just like we did with Marco's house on the first page. So the area of the triangle is base times height divided by 2. I prefer if you write the formula each time, just to make sure that you're starting off at the right spot. The base is 1, the height is 3, and so when we multiply that, I'm going to leave this as 3/2 for now, and that's centimeters, so that would be centimeters squared. I'll probably change this into a decimal momentarily anyways, but just for now I enjoy, well actually I always like fractions better than decimals, but for now I'm just going to leave it as a fraction before I change it into a decimal later on. And then if we find the area of this rectangle, that's length times width, or you can even write base times height, it doesn't really matter. So 4 times 3 for the length, and the width is 12 centimeters squared, and then the area of the total shape is 12 plus, and now I'll change that into 1.5, which gives me 13.5 centimeters squared. Now we'll move along to this. Looks kind of like an old style razor blade. These hash marks or dashes on the sides indicate that this is the same length as this, so we know this is 8. And just for clarity, we don't want to have all kinds of dimensions all over the place. We know that this is the same as this, and that is 3.3 centimeters. And it looks as though these are squares. So if this is 1 centimeter, then I imagine also this is going to be 1 centimeter. So we have to keep that in mind. So we could break this up into 5 rectangles and deal with those. I think what might be easier actually is deal with the whole, maybe make this whole again, make this into one large rectangle, and then subtract off the 4 smaller ones afterwards. So the area of the rectangle, again, length times width. If this square that's been cut out is 1 centimeter by 1 centimeter, that means that this side, this little piece is 1 centimeter, and this little piece is 1 centimeter, which means the whole length has got to be 10 centimeters. And then again, if this piece is 1 centimeter and this piece is 1 centimeter, then the whole length there would be 5.3 centimeters. I multiply those together, which gives me 53 square centimeters. Now I'm going to subtract off, and I guess I could, even though it's pretty obvious, each square is 1 by 1. So that's going to be 1 square centimeter, and there's 4 of them, so that's going to be 4 square centimeters, and then the area shaded, or the total area, is going to be 53 minus 4, which gives me 49 square centimeters. A lot of these types of questions, it's easier to get a total area and then subtract off the smaller ones as opposed to trying to break it up into all kinds of different rectangles and such. As we'll also see in example 4, it'll be a little bit easier that way too. Alright, let's go over here. Before we get to number 4, we'll get to number 3 and we'll do the classic stop sign, the hexagon. Now the area, remember from the first page of the lesson here, the area being simplified is the perimeter times the apothem divided by 2. Well, the perimeter, we don't know, but we do know the side length is 14.4 centimeters. So the perimeter is 14.4 centimeters multiplied by the number of sides, and because that's an octagon, there are 8 sides of it. And 14.4 times 8, just offhand, looks to be about 115.2. And that's a linear unit, such as centimeters. And so then the area of this octagon then is the perimeter times the apothem divided by 2. And so then I'm going to substitute in 115.2 multiplied by the apothem, which is 17.4. And then we'll divide that, whoops, not by that, we'll divide it by 2, because we're looking at areas of isosceles triangles inside the octagon. And we'll just multiply all that together and divide, and we get 1002.24 centimeters squared because it's area. I guess we could round it to 1 decimal place or 2, it doesn't really matter I guess, but it depends on, of course, what the question asks, where you round it. I'll just leave that for now. Chances are you'll be rounding just to 1 decimal place, so this would end up being 1002.2 square centimeters. And now to number 4. Okay, so it's a little trickier. We see we've got a large circle, and it is surrounding 2 smaller circles. We're given 1 dimension, and that's it for the entire shape. So we see that from the center to the edge of the smaller circle is 3 centimeters. So if we were to point that radius, well, I just gave it away, that is the radius of it. If we pointed that directly up, we see that that also is 3 centimeters. Or if we direct that down, it's also 3 centimeters. And so I suppose also what is understood, or should be understood, that this circle is the same size as this circle. So if this radius is 3 centimeters and this radius is 3 centimeters, then that means that diameter of the small circle is 6 centimeters, which means that the radius of the large circle is 6 centimeters. And then we can just kind of draw that in here, down here also. So then, if we want to find the area of the large circle, the formula for circles, for the area of the circles, is pi r squared, and we'll just substitute 6 in there, because that's the radius of the large circle. And so I'm just going to leave this as in terms of pi for now, because I don't really feel like multiplying by pi and getting all these decimals right now. I'll do that later on. And then the area of the small circle is pi times 3 squared, which is 9 pi. And we know there are 2 of them, so 2 is 18 pi. So the area of the shaded is 36 pi minus 18 pi, which is 18 pi square centimeters. I like to deal with exact values. That's why I just usually leave it in terms of pi, because it's just neat. There's no decimals. It's just 18 pi square centimeters. Now, for people who really like the decimals, they really have to put in the value of pi, I really suggest that instead of writing in 3.14, which is an approximation of pi, I would prefer you just use the pi button on your calculator. So hit the pi button, multiply by 18, and then round. This gives me 56, I don't know, 2 decimal places maybe, 1, I don't know. Let's say 56.55 square centimeters, because that came from 56.548 0.66 blah blah blah. So it could be 56.5 centimeters squared, or like I've written there, 56.55 square centimeters. Okay, so that is basically the area of composite shapes or composite figures. So if you need to review any of this, please go back and watch different parts again, especially perhaps if you need to review how we came up with the formula for the area of regular polygons. And once you've done that, then please start working on these questions, just to give yourself a little bit more practice. Okay, well, thank you very much for watching, and we'll see you in class.